Okay, thank you. And we next come on to shipborne antenna applications for naval systems. Tamer Yükseltürk.
Hello, thank you for giving me this opportunity for being here today in front of you. And also thank you for the organizing committee and for Profan. Today I will give you a presentation regards to shipborne Satcom antenna systems and applications on naval platforms. ASELSAN, let's start with ASELSAN. ASELSAN serves turnkey projects and also systems, subsystems, components, and equipment related with Satcom systems. Here's a great view which shows our product portfolio at the moment. We are under the sea, on the land, and also in the air. Airborne, Satcom, shipborne, Satcom terminals, submarine, manpack, flyaway, Satcom on the move, Satcom on the pause terminals are present at the moment and ready to deliver. And also at the same time we deliver network control stations, surveillance and reconnaissance satellite ground stations, and also the management software which links the terminals and the control station. And we provide terminal management software for each terminal specific to it. We start to work with satellite communication with Turkish military satellite communication system program on 2000. And as of today, all RF baseband equipments, ship, vehicular, and airborne terminals are designed and manufactured by ASELSAN indigenously. Let's talk about some couple of requirements that we face on naval platforms. Interference on the adjacent satellites is one of the key requirements. You should stay in the mask while you are transmitting to the satellite. And at the same time, specific to the antenna numbers and specific to the platform, you should know the platform and according to it make the location of your system. And also you should consider the interactions of the system with the existing systems on the ship. Non-transmit zone capability is also important, which is vital for the crew and also for the existing systems on the ship. You shouldn't transmit at all parts of the ship in order to make the other equipments work properly. Environmental conditions and EMI/EMC standards, including shock, is also important. We provide and our systems qualified for these military standards. Let me give you one video which shows our shock tests. It simulates the mine bombing in the sea. Our system should stay alive even the ship is facing this mine bombing in the sea. The aperture size of the antenna is also very important. Everyone wants to have the largest antenna on the platform, but there are limitations of the platform and also the shape of the system. Link budget should be flexible enough to overcome the worst case in order to work properly. Design of waveforms, SCPC, and other waveforms modulation techniques should be present in your Satcom systems. We have flexible link capability which crafts the link between the satellite and the terminal. Let's talk about some fundamentals in order to have a stabilized antenna system. Of course, if you have a Ku-band system, you should have a linear polarization, and you have to track the polarization track. You have to have the polarization tracking, and if the system will work on the equator, in order to come over some problems at the equator, for the keyhole effect, you have to have the cross-L axis should be implemented on your system. Different types of compensation techniques can be used. Closed loop or open loop tracking. We usually use closed loop tracking at which INS data, beacon signal, and additionally traffic signal is also used for the closed loop tracking in our systems. One of the indigenous product is the 1-meter X-band satellite communication terminal. It has been developed in-house by ASELSAN. The 3-axis stabilized carbon fiber antenna assembly is present at the moment, and we are integrating it to the fast patrol boats now at the moment. Satellite modem, LNB, BAC, MCOM control units, power distribution units, waveguide switch, combiners, distribution units, serial IP conversion units, gateways, dehydrators, UPS, CNM software are all manufactured by ASELSAN or by the subcontractors. It complies with the below military standards. 1.5 meter, 1.8 meter antenna systems is also present at the moment, and we are delivering it to the larger ships. One of them is landing helicopter dock project, which is currently ongoing on. And again, all the equipment is also designed and manufactured by ASELSAN or by the subcontractors of ASELSAN. Let's put some action in the event. This is a moment while we are testing our system. We can or we can simulate the ship movement in our steward platform, in our test house as ASELSAN. And another product that we have currently at the moment in our hand is the Ku-band Satcom Terminal. It has a very compact design. Data rates up to 20 megabits per second can be achievable. It has a composite pedestal. For this reason, it's lightweight, and this gives a high endurance to the equipment, to the terminal. We use direct drive motors. It gives a play-free performance and also stiffness to the system. The antenna system is designed which gives good. The reflector is designed specifically for this project. 2-axis movement and polarization tracking is present on the antenna now. And it's very easy to integrate to different platforms. Now we are trying to integrate this system for the UAV projects which are present in the country, Turkey. Let's talk about alternatives. Other presenters are also discuss these alternatives. Phased array antennas still have the has an advantage when we compare it with the dish antennas. It's low profile, but it has complex electronic elements now at the moment, and it's very hard to maintain the platform. It's very hard to maintain the system on the platform. It consumes high power, expensive. And sometimes it needs an extra mechanical stabilization according to the ship motion or according to the latitude. Metamaterial antenna systems are present, and it's coming. I think it deserves time, but it may be a solution in the future. And I think it's a candidate for the phased array antenna system and for the dishes in the near future. Thank you, and I'm open to your questions.